Good afternoon, students.
Afternoon, sir.
What did we do the last class?
I think I looked at the rules of integration.
Did I do any examples at all with you, or just went through the rules?
Yes, sir, we went through a few examples.
What was the last one that we did? 4x to the fifth plus 7x cubed.
I can't remember so far, sir.
You want to say you don't have the notes?
No, sir, that class I wrote the notes mentally.
Okay, got you. Can anybody remind me of what it is that we did? I know I went through the rules of integration.
Sir, we did up to number 3 in the examples.
Okay, the 4x to the fifth plus 7x cubed.
Yes, sir.
Mhm. All right, so I just need to play around with with a few questions. Just going to play around with a few questions and then jump into the Mhm. Ready? Let me share a few questions with you. Um, Next week, Friday this time, you're on a little class break because you would have done your exam earlier. I sent out the timetable. Please ensure that you communicate the information with your supervisors or places of work so that you can be given a time off for the exam. Please ensure that that happens. All right. So we have so we have 4x cubed plus 3x squared minus x minus 1. I want to put x to the 0 there for emphasis. I have minus 1. Now, remember when you're adding 1 to the power, sorry, when we're integrating, we're adding 1 to the power and divided by the new power. When we're integrating, we're adding 1 to the power and divided by the new power. So we're adding 1 to the power and we're dividing by the new power. We're adding 1 to the power and dividing by the new power. So we're adding 1 to 3 to give us 4. And then we're dividing by 4. So it's going to become 4x to the 4th over 4, see it right here, plus 3x cubed over 3, see it right here, minus x, remember this x raised to the first power, so it becomes x to the second power now, over 2. But I put this here because you have x to the 0. We know that anything raised to the power of 0 is 1. So don't have to write x to the 0. I really don't. But I put it there just for emphasis to show you that there is an imaginary x to the 0 beside the constant. There is an imaginary x to the 0 beside the constant. So when I add 1 to the power, 0 plus 1 is 1. And 1 divided by anything, well, anything divided by 1 is going to be the same thing. So I'm going to end up with a negative x. And because I'm integrating an indefinite integral, I have to have my plus c. All we do, integration finish right here. You notice that I'm not doing or have done is to go through this long thing that we did last class. That long thing we did last class really and truly wasn't really and truly wasn't, we call it no. It's not always needed, it's just so you can have that understanding with the application of the rules so that when you get the question, you know how to apply the rules. All right, so I don't have to slavishly run through everything that I did. But I have an option to just go ahead and just integrate one line, one shot, like I've done right here. Now, tell me if you have any questions for me. Oh, what I did was to cancel out. The 4's cancel out, so I'm just left with x to the 4th. The 3's cancel out, so I'm just left with x cubed. The x squared term remain as is, so is the x term plus c. And what you have in red is my final answer. Any questions?
No, sir, no questions, sir.
All right, go ahead and attempt question 5 for me, please. Quick and fast. Attempt question 5 for me, please. Quick and fast. Anybody finish?
Yes, sir.
Yes, sir.
What's the answer?
X to the 9th over 9 plus x to the 6 over 6 minus x cube over 3 minus 5x plus c.
Everybody agrees with that?
Yes, sir.
Quick and fast. Now we stay. Mm-hmm.
Sir, so you ready for the answer or?
Yes, sir. Born ready.
Sir, x5 plus x4 over 4 plus x squared plus x plus c.
Everybody agrees?
Yes, sir.
Sir, hold on, sir. Can you scroll up? Let me see 5. Let me just check a 15 actually. Thanks, sir.
Quick and fast. I give you a minute for number 7. Are you finished?
Yes, sir. But I'm not sure if I answer correct. We'll get x raised to the power 10 over 10 minus x raised to the power 8 plus x raised to the power 4 plus x plus 2.
How close were you? I know the first one was right.
Or that be far after?
Hmm?
Or that be far after?
No, man, the first one is correct. They said x to the 10 over 10. That's not what you said.
Yes, sir.
But to go for the second term.
Got x raised to the power 8.
But remember, now it's supposed to be negative 5x 8, x to the 8 power over 8. Remember, all you did, Mario, is just adding 1 to the power and divided by the new power. So everything that comes with it, you carry it back. So this negative 5x to the 7th is going to be negative 5x to the 8th. See here? Negative 5x to the 8 over 8. So everything it comes with, you're carrying it back. Everything it comes with, you're carrying it back. Did you say 6x to the 4th over 4?
No, sir. I said x to the 4.
Over 4 or just x to the 4th?
Yeah, that's x to the 4.
No, man, remember the rule says you add 1 to the power and divide by the new power. You add 1 to the power and then you're going to divide it by the new power. Adding 1 to the power, divide it by the new power. So it's not just to say x to the 4th. It has to be now x to the 4th divided by 4. But anything that comes with x to the 4th, the coefficient and everything you're going to divide over the new power. All right. So anybody else in the class got this one for the answer?
Mm-hmm. Yeah,
Yes, sir.
What about the rest of you?
Yes, sir.
All right. Here goes another one. Mario, number 8 is yours. I want to see how well you do this one. Mario, finish?
all right, sir. So
Mm.
I got x raised to the power of 11 over 11 plus x raised to the power of 6 over 6 or minus 2x squared over 2 minus 7x plus 2.
That's what you got?
Yes, sir.
Did you do this next? And cancel out the tools here?
No, never done that.
Yeah, man. Always try to reduce it to its lowest term. But very good, though. Very good. One more. You can fast. By the way, the rest of you got that one? Number 8?
Yes, sir.
Good job. Number 9, please. Let me know when you finish number 9, please. Come on now, what's the answer?
Sir, I'm not sure
Mm.
if you're right, but we'll get 5x raised 5x raised to the power 6 over 6. Um, yeah, x raised to the power 5 over 5. Um, 2x raised to the power 4 over 4 minus x cube over 3 minus x plus c.
That's what you got?
Yes, sir.
Good job. I recognize I could cancel number 2 and 4. So I can get x squared over 2. Always remember that. We always
Alright,
work in its lowest term.
alright, sir.
2 more and then I move. 2 is the one. What's the answer?
Sir, I got x cube over 3, 9 x raised to the power 2 over 2 minus 7x plus c.
Good job. All right. How are we feeling as it relates to, oh, I would say 2 more. We can faster that one. What's the answer for number 11?
Sir, I got x 8 over 8 minus 2x 6 over 3 minus x 3 over 3 plus c.
Was that the answer, Simon?
Oh, I forgot that. For the X4.
I know, it's two things I didn't hear you say. You didn't divide it by 4 for one, and then for the X squared part. What did you say for the X to the 6 part? What did you say again?
Yes, sir. I said X, 2x6 to over 3.
Okay. We left off the 4 though for the X to the 4th, right?
Yes, sir. I forgot to add
Mm.
the 1.
All right. I'm jumping to number 16. I'm jumping to number 16. Getting a bit more difficult, so I'm going to give you 2 minutes. Always stay.
Sir, X4 plus 5 plus 5x3 over 3 plus ln double dash x plus 3x plus 6.
So, sir, not you, sir. Sir, we couldn't have had.
Sorry, one minute, please, Mary. Simon, I was here asking you a question and never recognized I was muted. You said plus 6, Simon, or it's plus C you meant to say?
Sorry, sir, plus C.
Right. Go ahead, now, Shamari.
Well, I was starting to have. Well, I did put down 1 over x squared over 2. If I had put that, I would have get it wrong.
For which term? For this term here?
Yeah, for the 1 over x term.
Yeah, because remember, now this is going to be x to the negative 1. So the rule says when x is raised to negative 1 and only negative 1, you're going to have the ln function. If it's raised to negative 2, you won't have the ln function. Only when it's raised to 1, because you know what you're doing. 1 over x is the same thing as x to the minus 1. 1 over x is the same thing as x to the minus 1. And when you add 1 to the power, 1 plus 1 gives 0. And we are not allowed to divide by 0. So because of that now, the x to the negative 1 is a special case. The x to the negative 1 is a special case. So anytime you're given 1 over x or 5 over x or anything at all over x to integrate, Always remember it's going to be the ln function. Always going to be equals to the ln function. So just remember that.
All right, sir.
Mhm. And then you're going to have the, of course, the 3x plus c. Remember, your plus c is very, very, very important. All right, try number 17 for me, please. If you recognize today's class is not me, it's not about me doing the work. Yes, I have done the work, but it's for you to get an opportunity to do it, and then I'll confirm with you. Quick and fast, number 17. I'm leading up to a nice area. So work up. Say it again, Mario.
I got the answer. I'm not sure if it's right. So.
Go right ahead, Papa.
I got x raised to the negative 4 over 4 minus 3x raised to negative 2 over negative 2 plus ln plus 7x plus c.
Remember, I said to you that the ln function only comes into play when you have just 1 over x, not 1 over x squared or 1 over any other number, just 1 over x. The ln only comes into play when you have this form, 1 over x or x to the minus 1. So what we have, yes, x to the negative 4 over 4, I heard you say that. Also heard it say negative 3x to the negative 2 over negative 2, but this term is not correct because what I did was to convert this term from 1 over x squared to x to the minus 2. So x to the minus 2, I'm going to add 1 to x to the minus 2, I'm going to get x to the minus 1 over minus 1. So you recognize that I had jumped to question 16 because I wanted to introduce the ln function to you. So this is not the ln function. The ln function is only when you integrate in 1 over x. And 1 over x is the same thing as x to the minus 1. Once you have this function, 1 over x squared, you can go ahead and integrate as x to the minus 2. Yes, you can have 7x squared over 2. So that is the correct answer. So fix that one for me, please. It only works with 1 over x or x to the minus 1. Does not work any other time. Does not work any other time. All right. I'm going to project. All right. That is it for me. All right. So we're going to look at the indefinite one, the definite ones now. By the way, are you okay with this one now? Number 17?
I'm okay with this.
All right. Good job. All right. So we're looking at indefinite integrals, including a natural logarithm. Indefinite integrals, including a natural logarithm. So if you look at this function, you recognize that this function has 3 over 3x plus 1. Now, Remember, from the laws that I gave you, I can factor out this 3. I can factor out that 3 and call it 3, the integral of 1 over x, 3x plus 1. See it here? So this is now 1 over x. It is not as simplistic as this, 1 over fully x. This one is now 1 over x, which is 3x plus 1, right? So look at what we're doing with this function. So I was saying to you, look at rule number 4. So it's raised to the negative first power. Once it's raised to the negative first power, you are going to use the ln function. So that is going to be 3 times ln 3x plus 1. And it's the absolute value. Because remember, only positive numbers have logarithms. I can't find a logarithm of a negative number. That don't exist. So that's why we use the absolute value sign. That's why we use the absolute value sign. And like the power rule, we need to differentiate what is inside the parentheses. We need to differentiate what is inside the parentheses, and then we're going to multiply by the reciprocal. So the differential of what is in the parentheses is going to be 3. Because when I differentiate 3x, I get 3. When I differentiate 3x, I get 3. And I'm going to reciprocate 3. So 3 now becomes 1 over 3.
So you did as a differentiate. You mean differentiate or integrate?
All right, so you see what it is that I'm talking about? The differential of what's inside the parentheses is 3. So I need to multiply by the reciprocal of 3, which is 1 over 3. So that explains this 1 over 3 here. This 3 is the 3 that I factored out. That 3 is the 3 that I factored out. This one here. This 1 over 3 is the differential of the inside of the parentheses. Differential of 1 is 0. Differential of 3x is 3. And I'm reciprocating 3. So I'm going to get 1 over 3. And then I'm using the absolute value. And of course, I must have my plus c. And that's what I'll have. My final answer. ln, because 1/3 times 3 is 1. So that's going to have ln, the absolute value of 3x plus 1 plus c. Any question? If you don't see, talk to me.
I don't really see it, sir. Because I say, how you say differential and I've been an integration rather.
And that's what we'll find out. When I move to the exponential function, I'm also going to differentiate the function and then reciprocate it. So that's where it goes. That's where it goes. So even though we're doing integration, one of the things we do for integration is that we differentiate the function and then we reciprocate it for the final answer. So let me go through this one again. The question was 3, the integral of 3 over 3x plus 1. You will see that I can factor out a 3. I can factor out a 3. When I factor out a 3, I'm going to have this 3 here on the outside of the parenthesis, outside of the integration sign. And then I'm going to be left with 1 over 3x plus 1. That fits the form perfectly as 1 over x, except that is not the source of x, it's 3x plus 1. It's not the source of x, but 3x plus 1. All right? Now, when I'm integrating a function with 1 over x, it becomes a natural logarithm. So it is now ln, and because only positive numbers have logarithms, I'm using my absolute value so that at least I ensure that my answer is going to be positive. It's an indefinite integral, so I must have my plus c. But what I also have to do, as Shamari asks, I have to differentiate what is inside the parentheses and then reciprocate it. And then reciprocate it. Correct. 3 times a third is 1. And 1 times ln, the absolute value of 3x plus 1 plus c, is just ln, the absolute value of 3x plus 1 plus c. So one of the things I'm saying to you is that remember that ln is a natural logarithm. So we're going to differentiate what is in the absolute value, and then we're going to reciprocate it. And then we reciprocate it. Let me prove it. So if I let y be equals to this answer that I got from my integral, remember we said to you that the opposite of differentiation is integration, and vice versa. So if I have a function and I integrate it and I get the answer, when I differentiate it, I'm supposed to come back to my original question, because one is the reverse of the other. So let us check. So if I start with y equals ln, the absolute value of 3x plus 1. When I differentiate the ln function, the differential of ln is going to be 1 over x. So from I see the ln function, I'm going to have 1 over x. So therefore, I'm going to have 1 over 3x plus 1. Drop the ln and put 1 over 3x plus 1. See it right here, son? And then I'm going to differentiate what is in the absolute value. When I differentiate inside here, so I'm going to get 3. And this 3 is here. I'm going to multiply the 3, I'm going to get 3 over x plus 1. So you see why it is that I had to differentiate inside now, Shamari, and then reciprocate it. Because if I didn't, I wouldn't get by the same answer. If I never differentiate inside here, my answer here would have been 3 ln 3x plus 1. And that would not have given my original question. I had to only differentiate. I had to only differentiate this to get back this. If I had 3 here, the 3, I could factor out the 3 because it's a constant, and 3 times 3 can give me 9. So that end up with 9 over 3x plus 1, which is not what they gave me. So I had to differentiate inside the parentheses and then reciprocate it. Always remember that for me, please. Are you convinced now? Yes, no, maybe so.
Yes, sir.
What about the rest of you?
Maybe, sir. I'll catch up.
Tell me why it is that you're not seeing it. What are you not seeing?
Is that reciprocate, and then you have to differentiate inside the ln. So once I see more examples, I'll probably catch on.
So I'm giving you a function here to integrate from it. It says to integrate 8x plus 5 minus x to the negative first power d of x. And I'm putting a little notation here. Only when the power is -1, you would include the ln function. Did I say that up top here? Anybody remember me saying that up top?
Yes, sir.
Yes, sir.
Yeah, man. So only when you're differentiating rubbishness, only when you're integrating, only when you're integrating, and you have the negative first power, that you're going to be including the ln function. Why, sir? Because if you have x to the -1, as we do in this question, number 2 here, what is going to happen to us is that when we add 1 to the power, 1 plus -1 is going to be 0. So we're going to get rid of that term. And we can't just get rid of the term like that. So that's why we have to know account for it by looking at the natural logarithm. We have to account for it by looking at the natural log. What is the natural logarithm? You are going to know, say, ln x. And remember, only positive numbers have logarithms. So the value that you get right there for the ln function has to be a positive number. If it's going to be a negative number, the question can't work. Has to be a positive number. All right. So with that said, I'm sure you guys can do even at least 2 other parts, if not all three parts of that question. Start from it, please, quick and fast. Syntax. Finish working the question now? Hmm? If only you guys would talk to me. Jesus.
Yes, sir.
What answer you got?
4x squared plus 5x minus ln absolute x.
Incomplete. Incomplete. What else are you
Proceed.
supposed to proceed? Thank you. Thank you, Simon. You must have your constant of integration here plus C, or this question is not fully correct. Mario, how is the?
Yes, sir, I'm catching up.
Okay. So this part is not bad because you remember you're just adding 1 to the power divided by the new power. So it's going to be 8x to the first, to the second power because there's 1 up here already. So 8x to the second power over 2. And of course, when you reduce it, 8 divided by 2 is going to be equal to 4. Very good. Very good to know that you reduce it before giving me as the final answer. And and you're just simply adding an x to this 5 minus ln absolute value of x plus c. Remember your plus c. Remember your plus c. All right, I won't give you that one to do. Or you want to try it? Do you want to try this one? I did say troublesome. You want to try it? Yes or no?
Okay, no.
All right, so let us look at number 4. I'll only give you a hint for number 4, and then you'll just go ahead and do it on your own, and then I'll give you one to do on your own. So number 4, it gives us a division. What you're going to be required to do, you're going to simplify the function. How do you simplify the function? By dividing through each term by the x squared. So this x to the 5th is going to be divided by x squared. That 2x to the 4th is going to be divided by x squared. Now negative 7x cubed is going to be divided by x squared. And this x to the first power is going to be divided by x squared. So does the 9x. The 9 is going to be divided by the x squared. So having given you a push start to the question, I want you to take it from here. Well, let me get another line. The other line is when I simplify this, x to the 5th divided by x squared is going to be x cubed. These x squared going cancel into this and leave 2x squared up here. 2 of these will cancel into 2 of these and just leave negative 7x. This one will cancel into 1, so we're going to leave 1 over x, and then I have a 9 over x squared. Take it from this line for me, please, and complete the question. So if I don't ask you to finish, you guys aren't going to tell me that you're finished? Like seriously? Every day is the same thing?
Nervous, we nervous, sir.
No, man. Talk to me, man. Remember, sir, next week Friday. we not have much time in us, so we can't wait for time like that. Let me know so I can just go through. Waiting for the answer.
X to the 4th over 4 plus 2x cube over 3 minus 7x square over 2 plus ln x minus 9x to the minus 1 plus c.
Okay. So remember, we don't leave our answer as a negative index, so convert it to the 9 over x. You follow what I'm saying?
Yes, sir. Would I have lost marks because of that or no?
I wouldn't penalize you, but it looks untidy. I wouldn't. Yeah, on the exam condition, I may not penalize you, but if the answer to the question specifically say the student must know that they're supposed to write it in the stuff, it is a 5 marker, you'll get 4 out of 5. So you have to remember. So you are precise with all of your calculations. It's just a presentation now that is the issue. How the rest of you, Simon? Talk to me. How are you?
So the part that where it was 9 over x got me. I ended up
Okay.
writing ln and they put
No,
a 9x inside.
right. No, so remember the ln, and that's why I'm giving you so many of these questions of different types. Remember, the ln only comes in when you have x raised to the first power in the denominator, or when you convert it and have x to the minus 1. If x is raised to any other number other than 1 in the denominator, it is not a ln function. So you have to be able to identify when it is that you're going to be having your ln functions. Mario, how you stay? Next week, this time, you guys have a 1-day break while I am locked away at home marking papers so that you will know your fate come Monday morning. And I'm not yet finished with the syllabus, incidentally. All right. This one is tricky. This one is tricky, but it involves some of the similar things that we have been doing. So quick and fast, when you are done, I'm right here. When you are done, let me know. I'm giving you should finish this in about 2 minutes. At most 3 minutes. Start from it, please.
feel like me finishing, sir. But you say tricky and so I kind of fret about it.
Nothing too tricky about it, but I just want to frighten you. Let me get to the answer.
3x to the 6 over 2 plus x to the 4th over 4 plus ln x plus x plus c.
See there? Hit that. Hit that. Simon,
Yes, sir, I got it as well.
good job. Mario,
I'm giving it to attempt.
what you say?
I'm giving it to attempt because I'm doing something.
Anybody hear him say? Come in here, nothing.
You hear me now, sir?
Yeah, say it again.
I didn't get to attempt it first. I got to this one.
Oh, you didn't get to attempt it. Okay. All right. All right. So I'm moving from there now. I'm moving into my definite integral. So what we have been looking at all along was what we call the indefinite integral. The indefinite integral has no upper limit, has no lower limit. Whenever we integrate it, we must put r plus c. We have to put r plus c because it's the function was indefinite. We don't know an upper limit. We don't have a lower limit. But when we move into our definite integrals now, our definite integrals have an upper limit and a lower limit. Has an upper limit and a lower limit. When I integrate these definite integrals, there's no more need for me to put the plus c because I know specifically where it is. Let me explain what it is. This is like. It's like me asking you where to find Excelsior Community College. You say Mountain View. And leave me at that. Mountain View is a long road. It's a very long road. But, so that is the indefinite integral. The definite integral now is to say to me that it's 137 Mountain View Avenue. So I know exactly say, me I go 137. So I know exactly what it is. So I can drive confidently. You know, sometimes when you're driving to a venue that you don't know, and you compare the journey when you're coming home, what can you say? You're driving to a venue that you don't know where you're going. But upon returning, what can you say in comparison to the journey?
That the
Can I get-
distance was short, I don't know.
Okay, Simon, you're coming in to say something?
It's easier to leave than if you were coming. The journey was harder, but when you're leaving, then it's easier because you know where you went. Somewhere along those lines, sir.
Absolutely. So if I'm trying to find somewhere, it's going to take me longer to get to where I'm going. Because if you say to me, let us go to Port Royal, when you reach a roundabout at the airport, you don't make the right turn to go to the airport, but you go straight across the roundabout. I'm going to say, all right, fine. I can drive confidently to the roundabout because I know where the roundabout is, but I don't know where Port Royal is thereafter. So I am not going to be driving at my 80 kilometers. I may be driving slower because I don't know where I'm going. However, on the way back, because I know where I'm coming from and where I'm going, the journey is going to be shorter or seamless. So normally when you're to journey, especially if you don't know where you're going, it's going to take a little longer. So if it's a half an hour drive too, I guarantee that on your way back, it may take you anywhere between 20 and 25 minutes because you know exactly where you're coming from. So you can get to your destination more confidently. Right? That's exactly what the definite integral is. Definite integral tell me specifically what I want. This you look for, and that you will get. All right? So now, do me a favor. I am giving you this question to do. My upper limit is 3, and my lower limit is 1. However, I'm not interested in you applying the limits just yet. What I want you to do is to integrate the function for me. So go ahead, integrate x squared plus 3x plus 2 for me. When you would have completed that integration, let me know, and then I'll take you through to the rest of the question. Same thing I'm talking about. You know how to integrate the function, but you don't know how to apply the limits. You know where to find the roundabout for the airport, but you don't know where to find Port Royal. You know how to integrate this function. So you can go ahead and integrate it. When you reach at that point, that milepost, you're going to stop, and then I'm going to come through and just do the things for you. All right? I'll give you a minute, please. Let me know when you finish.
Finish, sir.
What you got for the answer?
X cube over 3 plus 3x square over 2 plus 2x.
All right, good. Stop. You're not going to put no plus C. All right. So what you're going to do now is you're going to have your brackets. You're going to put your upper limit up here, and that's why it's called the upper, because it's going to be up top. Then the lower limit is going to be down here. Then in order to do the question, you're going to substitute the upper limit into the whole function. Then you put a minus sign. And then you can substitute the lower limit into the said function and then work it out. See it here? So anywhere in the function you see x, you're going to substitute the upper limit. Not upper limit and lower limit together now. You notice a color coded. So up here, sir, the upper limit is blue. So everywhere in the function, I see x and put in my upper limit. So this is 3 cubes over 3 plus 3 times 3 squares over 2 plus 2x. And when I put all of that in there, I put those in parentheses, separate it nicely, and then put my upper limit, my lower limit into the other function. 1 cube over 3 plus 3 times 1 squared over 2 plus 2 times 1. And then I want you to evaluate that and tell me if you get the same answer as I did. I'll leave it like this. I want to see if you get the same answer as I did, right? I'm going to step away for 2 minutes. I should be back the time when you're finished. Let me know how you stay. Well on now. What on?
Sir, I got an answer.
You have to tell me now. What is the answer?
Just finished, sir.
What's the answer?
Sir, I got 74/3.
Same.
Mario, you're not participating. You are correct. Very nice. That's all that there is to it. That's all that there is to it. I'm giving you that one to do for me. Start now for me, please, quick and fast. So much work we're getting done today. Let me know when you're finished.
Finish, sir.
What do you get for your answer?
112/3.
Simon?
So I got 82 over 3 unit square.
112/3. All right. So you notice here now that the units here is unit square. So whenever you're finding a definite integral, you're going to have unit squared. So Simon, check where you went wrong again, please. Just recheck your calculation for me, please. It's supposed to be 112/3. Do that quickly for me, please, Simon, while we work on another question. All right, Simon, so do that for me quickly. And then the rest of you move on to this one, please. Mario, I want you to be a part of this. Shamara, move on to number 5 for me, please. Simon, you're going to double check your answer to see if you get the 112. And then we'll come back to this one here. Quick and fast, please. It's now 7:54. We have an hour left, and I have a few other things that I want to cover.
Finished, sir.
And your answer is?
16/3 unit square.
Simon, were you able to fix the other one? You got the 112, Simon?
Yes, sir. I found out that I didn't add a put a cube for one of them in the lower limit.
Okay, great. Did you complete this one?
No, sir, I'm not finished with that yet.
All right. I will give me half a second more, please. Mario, where are you?
So I'm at the second stage, sir.
Please so hurry. 1 more minute and then you said 16/3,
Yes, sir.
Shamari? Okay. All right, so you are correct. The rest of you try and work towards the 16/3 unit squared. Shamari, move on to the other one, please, number 6. Simon, you got the 16/3. Mario, you got the 16/3.
Yes, sir.
Okay, good, Mario. Simon? Finish this one. Finish number 6, Shamari.
Not as yet, sir.
Okay. Let me know when.
Finish, sir.
And what is that?
47 over 2 units square.
That sounds correct. Bueno. All right. Gonna give you. How you feel about it, no, Mary? Shamari?
Pretty good about it, sir.
I'm gonna give you this other one to do. The pair of you, I want you to try and complete the question with the same 23.5 or 47 over 2 units squared. I want you to try one, Shamari, where one of the limits is 0. So I want you to do this one here for me. Number 7.
All right, sir.
Cool.
Finish, sir.
And your answer is?
Negative 25 over 4 units square.
Very good. Simon, Mario, did you get the 47 over 2?
Sir, I was working number 7, but I got the negative 25 over 4.
Okay, good job. Great. But I want to find out though if you got the 47 over 2. Mario.
Yes, sir, I got them 47 over 2.
Okay, good job. All right. All right, looking good. I am going to give you all. I'm going to give you all number 11. All right, so all of you, attack number 11 for me, please, quick and fast. I want to see if I can reach to area under the curve, even the introductory part of it. Very nice. You guys are doing pretty well, actually. Very nice. 3 minutes. When you finish, let me know.
Finished, sir.
And what is your answer?
85/4 units square.
Is he correct, Simon? Mario?
Yes, sir.
Mario, man, like you're dealing with me, you know. You're dealing with me like a stepchild. Are you still in the class, Mario?
Yes, sir. Yeah, hear me, sir?
Yeah, you know, but Mario, you now do no work. You do the work? Are you busy doing something else?
No, sir, may I do it now? Just now finish fast, you know.
I don't think I have your 100% attention, Mario.
Yes, sir, you do.
Okay, okay. All right. All right, so I'm going to stop share for half a second. I like where we're at. We have been doing quite a bit of questions. Aha. I bet you can't do that one there. Because I had done that with you. Yeah, I don't think we can get. All right, I'm going to give you one last one. But I know you guys not going to be able to get it. I know you guys not going to be able to get it. I've given you one where the zero was the lower limit. No, I'm giving you one where the zero is the upper limit. If you don't get it, that's fine. But I know it's going to be difficult for you to get this one correct. All right? Give it a try for me. Let me see if I'm wrong.
Finish, sir.
What answer did you get?
59/6 units square.
Simon, tell him same wrong. Where you get, Simon?
Sir, I got 17/6 units squared.
Mario, what you got?
I haven't finished, bro.
Look at where you went wrong, Shamari. Did you have you got 0 for the first part, right?
Yes, sir.
You got -1/3, is also +1/3 use right here.
A -1/3 right there. So, but then it changed. Well, I see where I go wrong, sir. You see 7/2.
Mm-hmm.
We did have it as
As
negative
negative,
when time we just
right?
work it out. Yeah.
Right, because when you square the -1, you can get a +1.
Jano.
Yeah, man. But that was a good attempt. My initial talk earlier was was sarcastic because I know you guys are doing pretty well. It was I guess if I didn't say that it threw you off because you're getting all of them correct up to now. But I still believe that you're understanding. All right, Mario. It's now half an hour before, and I must move into now the integration of some exponential functions, which is not bad. I have two of them. Let me just put both of them on at the same time. I have two of them. And I have two of them, and it really isn't bad. I'm gonna give you an opportunity to take 2 minutes each to read through those two rules. Then I'm gonna come in and show you what it is. I expect them to give you a question like this on the exam, on the essay type paper? Maybe not. But I do expect them to give you something like this on the multiple choice, like a 1 mark. So I'm not going to spend a whole heap of time on it. You hear what I say? I expect them to give you something like this on the multiple choice for a 1 mark. So if you get 2 questions at 2 marks, so I'm not going to be spending more than 5 minutes on this thing. So I'm going to give you 4 minutes each, 4 minutes in total, 2 minutes each to read through it yourself. And then I'm going to come in and just put the icing on the cake and then move on to something else. All right, starting now. So what it is that it is saying here is, when I integrate an exponential function, I said to Mario, to show Mario at the start of the class when we were doing the exponential, the logarithmic function, and I said to him that we have to differentiate on the inside of the function, and I think I did say to him that for the exponential function, I will also have to differentiate the function and then reciprocate it. Don't know if he was hearing what I was saying, but this is it. When I integrate the exponential function e to the ax dx, what is going to happen is the integral of the exponential function e to the x is going to be e to the x. So you notice my answer is going to contain the same thing here, e to the ax here, e to the ax. What I'm going to be doing now, I'm going to be differentiating the function itself. And when I differentiate ax, I get a. You see, come back again, Shamari. I differentiate the function and I get a. The power, I get a. And then what I'm going to do is reciprocate it, so I get 1 over a. So the integral of and I want you to pay me attention, you know. The integral of e a to the x dx is going to be the differential of the power, which is a. I'm going to reciprocate it. I'm going to get 1 over a. And then I'm going to write by the exponential function, e to the ax plus c. Does that make sense?
It's surprising, say it make look a sense, sir.
Yeah, man. It's just a rule. It's just how the rule runs. Right? So you see that the logarithmic and the exponential, they both have something in common. So and if you look back at the laws, you'll see it in the laws there, right? In the question that I gave you on the law, in the law there, the law of integration there, it says something like the integral of e to the kx dx. I'm going to integrate e to the kx dx. I'm going to integrate kx, and I'm going to get k, and then I'm going to reciprocate it. So I'm going to get 1 over k. So I'm going to get 1 over k, e to the kx plus c, right? Once it's definite, indefinite, that is. All right. However, there is an intermediate that I need to talk about, because if I talk about that intermediate, the second one will come into play. The second one will come into play. So it says differentiate the function and then reciprocating it times the given exponential function plus c. This is just the workout part of it. Work with me now. Do you notice that I have ln e inside here? So when I differentiate this, I'm going to get a. But I'm also going to be having the ln of this function e here. But it so happens that ln e is equals to 1. This e, the exponential function, I'm going to have ln e. But it so happens that ln e is equals to 1. So 1 times a is simply a. Watch this one. So this one is e to the ax. This one is e raised to the ax dx. There is no e here, but this is a raised to the bx dx. Do you recognize that I'm going to differentiate the power again? And the differential of bx is going to be b. And I have 1 over b. But this time now, I must have my ln a. This time, Up here, I had a ln e, but I could ignore it right here because ln e is equals to 1. I don't have a value for ln a, so I have to go work out what ln a is. So I have to write ln a here. And of course, write back my exponential power function, a to the bx plus c. So just remember, if you know this one comes easy. And there are only two of them. If you know this one, the top one, the bottom one come easy. Let us go again for the top one. I need your undivided. Mario, make sure that I have your attention, please. All right, let's go. So I'm integrating e to the ax dx. I will have to differentiate the power, and the differential of the power ax is going to be a. I'm going to reciprocate it. I'm going to have 1 over a times ln of the base. Ln of the base. The base here is e, so I'm going to have times ln e. And I'm going to write by the exponential function e to the ax. E to the ax plus c. Now, ln e is equals to 1. So a times 1 is a. So my answer reduces to 1 over a, e to the ax plus c. In this here case, if I say a, b, dx, again, I'm still differentiating the function like I did the power, like I did up here. The differential of the power bx is going to be b. Just like up here, when I reciprocate it, I am going to reciprocate it. Just like up here, when I put ln e, ln of the base, I'm going to put ln of the base, ln a. And just like here, when I put e to the ax side of the answer, I'm going to put a to the bx. I'm writing by the exponential function. See, write by the exponential function. Here, I write by the exponential function. C right here, plus c. No. A has to be greater than 0. A cannot be equal to 1 because ln1 is equal to 0. And I can't have a 0 in the denominator. So a cannot be equals to that. Tell me that you see what I'm talking about here. Say it again, Simon. Simon, what were you saying?
No, that was me.
Oh, who was that? Maria, that was you?
Yes, sir. I would say not really, sir, but maybe when I say the work, I might get to get some.
All right, let us look at that working out. E to the 2x. Remember I said to you, I'm going to differentiate the function 2x, don't?
Yes, sir.
Okay, right. I'm going to differentiate the function, I'm going to reciprocate it, don't?
Yes, sir.
So I'm going to get 1 over 2, don't?
Yes, sir.
But because the base here is e, I'm going to write ln e, don't?
Yes, sir.
And then
1
times by
over 2 ln e.
Right. And then put back the e to the 2x, don't?
Yes, sir.
But ln e is equals to 1, don't?
Yes, sir. 1 over
So I'm going to have 1 over 2
1.
e to the 2x, don't? Plus
Yes,
c.
sir.
1 over 2 e to the 2x plus c. That not hard, you know? A while ago, we just did it mentally a while ago. We just did this question mentally a while ago. It's not hard, man. Trust me. I give you the laws, you have the laws, and we get the question, we're good to go. I promise you. I want to give you something to know that is going to be beyond you that I don't explain it. I know some of these concepts are difficult concepts, but what I try to do is simplify the concepts for you so that you can understand it and follow what is happening. All right, so
It works, sir.
yeah, man, it does. Have to work, you know. Yeah, teacher, you know. And if me can't if I can't simplify the material for you, I would have failed as a teacher. And funny enough, when I was studying these things, the material is sometimes it's kind of hard for me, right? But of course, when you study and study and study and you get the stuff, you have to find a way to explain it so that you can get it. All right, work with me now. Mario, I'm going to go back again. So when I have this, the exponential, sorry, the integral of the exponential function to a power, the integral of e to the ax, and this is just a general term. This is just general term. This again is general term. Watch me. The the integral of e to the ax, we are differentiating the power and then reciprocate it. When we differentiate ax, we're going to get a. And then we're going to reciprocate the a, so we're going to get 1 over a. But we're going to have 1 over a, but we're going to put we're going to put ln e, ln of the base, and the base is e. And then we're going to write back e to the ax. C right here is a plus c. But we know that ln e is 1, so we can drop it and just put 1 over a e to the ax plus c. If the question comes in a way where the base is not e, dog them or supper, because we can't just cancel it out. I forgot to write it in the answer. So I forgot to put 1 over b. And why b this time? Because the power is b of x or bx. So when I differentiate bx, I'm going to get b. So I'm going to put 1 over b ln a times all of this plus c. See here? Times all of this plus c. And we know that a is greater than 0. A cannot be equal to 1. All right? I will just do that one example. Now, the other example I have here is going to be something like this one. Now, remember, when you are given the exponential function, you can leave out the ln e because ln e is equals to 1. When the base is not e, and
Write it back.
you have to write by the ln e, right? You see up here, so it says a is greater than 0. So a can be 2, 3, 4, 5, 6, 7, 8. A can be negative, and a can be 1. It will be greater than 0. It says greater than 0, and it is not equals to 1. Right? So watch me now. For the 1 here, I'm going to differentiate here. So when I differentiate the power, what am I get?
X plus 5.
Good. So we know that 2x plus 5, now we put 1 over 2x plus 5, e to the x squared plus 5x plus 2 plus c. 1 over 2x plus 5, e to the x squared plus 5x plus 2x plus c. And differentiate up here, so reciprocate it and write back the whole of this. Tell me say that hard. That hard?
No, sir.
I differentiate the function. I differentiate x squared plus 5x plus 2. Once I differentiate it, I reciprocate it. And when I reciprocate it, I just get multiplied by everything right here. So remember, you know, this is really 2x plus 5 in brackets times ln e, because the base here is e. But we know ln e is equal to 1. So we're not going to work hard, we're going to work smart. Because we're going to make them know, so we know, say ln e is 1. All right? Watch this one now, though. We now get a 1 here. We can't get a 1 here. This one can be for homework. Time is running off, and there's one of them that I want to look at. E to the x squared minus 7. When I differentiate x squared minus 7, what do I get?
You get 2x.
So it's going to be 1 over 2x, ln e, e to the x squared minus 7. But ln e is equals to 1, so it's going to be 1 over 2x, e to the x squared minus 7 plus c. See this up? 1 over 2x, e to the x squared minus 7 plus c. Really not difficult. Now one more and get to. G's on P, sir. But I never did a question like this before, did I?
This I want to hear the a to the bx. Dx.
All right. Very good. Very good. Very good. So come. Mental mathematics now. I don't want nobody to write anything. We're going to do this mentally. We're doing it in stages. So the first thing to do is what?
Differentiate the power
Very good. And when we
function.
differentiate 5x, we get
5.
good. So it's going to be 1 over 5 ln 2. Don't.
Yes, sir.
Times 2 raised to the 5x plus c. See here? 1 over 5 ln 2 times 2 to the 5x plus c. Tell me, say that hard. Not bad. Really not difficult. So the difference between the exponential function and my constant as a base, when I have e as a base, I still going to find ln e, but ln e is going to be equals to 1. So I can ignore that. But once it is not e, I'll have to write ln of that number. And remember, a is going to be greater than 0, and a cannot be equal to 1. So a is either 2, 3, 4, 5, 6, 7, 8, you name it. All right. So that's what that one is. There's nothing more to that one. All right. This is going to be the last one that we do in class today. Can you just look at it? Anybody, somebody, anybody. Matter of fact, you know what you're going to do? I'm going to give all of you an equal opportunity. It's now 2 minutes to 9. Take a minute. Take a minute to do that question for me. Take a minute to do that question. Number 6. All right, talk to me nice. What the answer?
Yeah, that answer, I'm not sure if it's right, sir.
Talk to me, Mario. Let me know.
Well, 1 over 2 ln 3x squared plus x plus 2 plus 2.
Say it one more time.
1 over 2 ln 3x squared plus x plus 2 plus c.
All right, I hear you. You miss out something though, but I hear you. Simon, what say you?
Sir, have 1 over 4x minus 1 ln 3 e to the 2x squared minus x plus 3 plus c.
All right, you put in something in yours. Shamari, let me hear what you said.
1 over 4x minus 1 ln 3 to the 2x squared minus x plus 3
You're
plus
correct.
c.
You're correct. So you're correct, Shamari. Simon, you put in an E right here, so why put in an E? You see no E number function, Simon?
Oh,
Right.
apologies, sir.
Yeah, man. So that's the only mistake that you made. All right. So Mario, Remember, you know, you got a piece of the question right, you know, Mario. You got the LN3 part right, but you did not differentiate the function. You said 2x. You have to differentiate the power up here, so. And when you differentiate 2x squared minus 1 plus 3, you're going to get 4x minus 1. So it's going to be 1 over the 4x minus 1, ln of this number here. And then when you write all of that, you're going to write back everything in another question, but the original question gives you. See, the original question plus c. You see that, Mario?
Yes, sir.
Come on, please. All right. Just one quick announcement. I am almost there. I have integration by substitution to look at. You guys are understanding the integration. I'm really proud of you with that. And then I have the applications of I may do 1 or 2 double integral question with you, double integration question with you. Then I have the applications of integration to do with you, which is really not bad because you have been doing it. All of what we did tonight would have been area under the curve, which is really an application to integration. The only thing that I have to show you now is chances that I may give you a figure. And I want to show you them give you a figure how to just work with it. So it's not a big, I can use 10 minutes and do this stuff because you have been doing this. Remember those questions that we did with the definite integrals? You have the upper limit, lower limit, and the function dx. That's exactly the application to the question, but sometimes let me give you a function to work with it. And then what I have to do with you next is just to do some L'Hopital's rule. L'Hopital's rule is really limits, but we're using differentiation to do the stuff. And I believe when I would have completed that, I should complete the the curriculum for your stuff. So what I'm saying to you is, I know Monday is election day. I will be going for those 2 hours. My aim is to finish the syllabus on Monday. My aim is to finish the syllabus on Monday. On Wednesday, God's willing, we are going to be touching base with some of the questions, I mean, past paper questions, etc., etc. Over this weekend, I'm going to give you what I call a take-home piece to do for me. More than likely, it's going to be on Sunday. That it's going to be a timed piece. So I may give you an hour and a half, I may give you 2 hours. I'm not going to give you in the morning because I know some people go to church in the morning like myself. So more than likely will be in the afternoon, you know, and late afternoon too. Where it is that you can sit, use the 2 hours thereabout, do the questions. Go ahead.
I mean,
Go ahead.
we have another graded piece Sunday as well.
From 5 to 8.
You have a graded piece from 5 o'clock to 8 o'clock?
Programming. Sure.
All right. All right, then. Thanks for that information. All right, don't worry about it. Thanks for that information. It's all right then. So I won't give you anything over the weekend, because if you're gonna have that to do, I want you to be able to focus on that. All right. My final thing though is, some of you are moving. Others of you have done just one piece on Edicosoft. Let me just say this one last time. Edicosoft accounts for 20% of your final grade. 20% of your final grade is Edicosoft. The take-home piece that I'm giving you would be 20% of your final grade as well. That's why you're going to end up with 40% of your final grade. And the exam amounts to 60% of the final grade. Now, let me just warn you guys. For the last time, I've done it so many times before. Let me give you a final warning. Next week, Friday this time, hopefully, should be finished marking the exam papers and tally my grades to upload the grades on the system by the latest Saturday morning. For sure, my absolute cutoff time would have been Sunday night, because Monday, the grades will have to be released to you guys to let you know your state or your fate. It simply means there will be no extension to EducaSoft. By next week, Friday morning, before your exam, all my pieces on EducaSoft must be completed. If not, the incomplete pieces will attract a 0. They're going to be averaged. And trust me, you wouldn't want that to happen to you. I'm saying this to say to you again, I am not going to be late with my submission because I'm waiting on a student. It will not happen. It will not happen. So this weekend is going to be a good weekend for you to do your programming as well as to complete your EducaSoft. So you see what I'm doing? I am postponing my take-home math for you completing your EducaSoft outstanding pieces. I will sort out my math one day next week. Those are my few words. In Jesus' name. Have a good one. Talk to you.
Before you leave, sir,
Mhm.
you could have scroll up to the where you have the rule for the indefinite of the exponential function, the integral of the exponential function. I just want to screenshot it.
Are you seeing it?
And yes, sir. And do you have the rules for integration on this document, or it's a different document?
I'm going to be sending it to you.
All right, then, sir.
Cool.
And about EducaSoft, sir, you know,
Mhm.
sir, it mashed me up, sir, and then it's like I can't do this next part of unit 1 without getting a certain percentage on something else. So it would have possible to redo some of the stuff that I did already.
Long time I reopened it in Shamari. Long time. Weeks ago when I saw the grade. So you need to move on from where you are now. It's
All right, then,
20%
sir.
of your final grade. 20% of your final grade pop up. You can't play with that.
Because I did I try again today, sir, but it did I show me some do it already.
No, man. You will see a blue button to the right that says resume.
Mm-hmm.
All right.
All right, I'll try again then, sir. But if it don't work, I'll message you.
No problem. All the best.
You as well, sir.